The sine double angle identity is derived from the sine sum identity. If we substitute u for v, the given angles all become u. Since the values are the same, it becomes twice the value. This is the sine double angle identity. The cosine double angle identity is derived from the cosine sum identity. Similarly, if we substitute u for v, the given angles become u. It takes the form of cosine squared minus sine squared. Using the Pythagorean identity, we can replace sine squared with the following expression. Upon simplification, we get an expression with 2 cosine squared term. Again, using the Pythagorean identity to replace cosine squared, we end up with an expression involving 2 sine squared term. Thus, we obtain the cosine double angle identities with 3 expressions. The tangent double angle identity is derived from the tangent sum identity. By substituting u for v, the given angles become u. The numerator contains twice the tangent, and the denominator has tangent squared. This is the tangent double angle identity. Power-reducing identities are derived from the cosine double angle identity, and they are crucial for later deriving half-angle identities. The first identity, when rearranged for cosine squared, this expression becomes as follows. Dividing both sides by 2 yields the following. The second identity, when rearranged for sine squared, this expression becomes as follows. Dividing both sides by 2 yields the following. The third identity, in the numerator, the expression for the previously obtained sine squared is included, and in the denominator, the expression for cosine squared is included. Simplifying the rational expression results in the following. These are power-reducing identities. Now, let's explore half-angle identities, which are derived from power-reducing identities. Starting with the sine squared expression. Taking the square root on both sides, and substituting u as theta over 2, we get the sine half-angle identity. Here, the plus or minus sign for sine is determined by which quadrant theta over 2 lies in. Similarly, for the cosine squared expression, taking the square root and substituting u as theta over 2 gives the cosine half-angle identity. As in the previous case, here, the plus or minus sign for cosine is determined by which quadrant theta over 2 lies in. The tangent half-angle identity is derived in a similar manner for the tangent squared expression. And substituting u as theta over 2, resulting in a fraction. This expression, when subjected to denominator rationalization, yields the second expression. And when subjected to numerator rationalization, results in the third expression as follows. In the remaining 2 cases, the plus or minus sign is automatically determined by the cosine and sine values of theta. These identities are useful in problem solving, so it's important to remember them. See you next time.